Hello everyone, I welcome back you all to my next video. As you all know, I am Chitrashri. I am currently pursuing my BE in Sri Venkateswara College of Engineering in the Department of Computer Science and Engineering. In this video, I will be discussing about the subject analysis and design of algorithm related to the topic Prim's algorithm. The content of this video is as follows. Initially the introduction, the next is steps in solving the Prim's algorithm and the logic present in the algorithm, the example program and finally the application. Here is an introduction related to the Prim's algorithm. Before applying Prim's algorithm on any given problem, the user must know some of the key points like it works only for connected, undirected and the weighted graph. It usually follows greedy method for problem solving. Greedy method is nothing but it is one of the problem solving approach. It usually builds up a solution step by step by choosing the option that offers frequent or immediate benefit. Examples for greedy method like Prim's algorithm and Kruskal's algorithm, which usually works for building a minimum spanning tree, and Dijkstra's algorithm for finding a shortest path, and Huffman's coding for data compression. It is used to construct a minimum spanning tree with no cycle. Spanning tree is nothing but it is one of the subgraph. It contains all the vertices of a graph. Minimum spanning tree is one of the tree of the weighted connected graph, which usually has a smallest weight. Here is a graph that contains five vertices or the five nodes. Uh, there are two more trees or the two more graph which are constructed from the original graph. It also contains the five edges, but the spanning tree cost of first graph is 13, whereas the second graph is 7. So the first graph is considered as a spanning tree and the second graph is considered as a minimum spanning tree. Usually there are four steps in solving the Prim's algorithm. Prim's algorithm usually finds a minimum spanning tree by selecting the edges from a graph one by one through a sequence of expanding subtrees. The step one is select any node and the step two is connect it to the nearest node. If two or more nodes are equally far away, choose any one at random. Either we can follow alphabetical order or the numeric pattern. The step three is connect first node or the one node already selected to the nearest unconnected node. The step 4 is repeat until all the nodes are reached. The connection of all the nodes takes place such that there will be no cycles are formed. Here is an algorithm or pseudocode for solving any problem using Prim's algorithm. The first 5 lines is used for initialization and the rest 6 lines is used for constructing a minimum spanning tree or by building or for building a networks between every nodes. For each vertex u, it must be belong to the vertices of graph G, and the initial weight of vertex u will be set to infinite since it is the first element, and since it is the first element, it obviously it will be having no parent, and so the parent of u will be also set to nil. And for the minimum spanning tree, u is the first element and q is the first element, so the cost of minimum spanning tree will be also 0. Usually this Prim's algorithm works for priority queues, so all the vertices of graph G will be dumped to the priority queue, which is represented by the capital letter Q. Now comes the construction part of minimum spanning tree. While priority queue is not empty, the user must start extracting the adjacent nodes or the adjacent vertices of a selected node U from the priority queue. For all the selected vertex, they are usually represented by V. It should be the adjacent of U, and if the selected vertex belongs to priority queue, which is represented by capital letter Q, which means it is not already presented in the constructed minimum spanning tree. And if the weight of the edges between U and V, if it is less than the key value of V, which means if the selected edge is less than, is having the lesser weight than the remaining vertex, which are also the adjacent of U, then U will be has made as a parent of V, and the key value of V is updated by adding the weight of the edges between U and V. one of the examples where we are finding minimum spanning tree and as well as the minimum cost using a Prim's algorithm. Here they have given one of the graph which is connected, undirected and as well as the weighted graph. The weights are mentioned above the edges. Here 10 is a weight or the cost of the edge between the vertex 6 and the 1. In a step 1, they had initially selected the node 6 or the vertex 6. Here vertex 6 has the two connections. It is connected with 1 and as well as it is also connected with 5. With 1, the weight is 10 and with 5, it is 25. So we had to find the minimum cost between 10 and 25. The lesser weight is or the lesser cost is 10. So in a step 1, the node 6 is connected with the node 1 with the cost of 10. When it comes to step 2, since 6 has another one vertex which is connected, that is 5. So it is copied from the graph and it is pasted here, that is 6 and 5 has a weight of 25. In a step 3, they are connecting 4 with the cost of 22. Here 5 has two more vertex which are joined with it. 5 is connected with the vertex 7 with a cost of 24 and 5 is also connected with the vertex 4 with a cost of 22. So the minimum cost is 22. So in a step 3, the node 4 is joined to the node 5 with a cost of 22. And when it comes to the step 4, the node 4 is connected with the 7 with the cost of 18 and it is also connected with the 3 with a cost of 12. So we had to find the minimum. 12 is a minimum. So in a step 4, 4 is connected with 3 with a cost of 12. When it comes to 3, there is only one node connected, that is 2 with a cost of 16. So there is no option. In step 5, we are connecting node 3 with a node 2 in a cost of 16. And the last remaining vertex is 7. So 2 is connected with 7 with a cost of 14. So but 4 is also connected with 7 with a cost of 18 and 5 is also connected with a 7 with a cost of 24. So the minimum weight between 14, 18 and 24 is 14. So we are connecting vertex 2 and vertex 7 with a node of 14. In step 2, after step 1, that is 6 is connected with 1, we can also move in this way also. That is 1 can also be connected with 2 with a cost of 28. But the node 3 is also connected with 2 with a lesser cost than the 1. So instead of rather than moving 1 with 2 in a step 2, we started moving connecting 6 with 5. So the minimum cost, so step 6 will give the minimum spanning tree with a cost of 99. Here are some of the applications where we can apply Prim's algorithm, like network design in telecom and computer networks, to design networks with the nodes like office or house with minimum total wiring cost. Road and railway network, planning efficient layouts for roads or railways to connect multiple cities while minimizing construction cost. Cluster analysis in ML, in machine learning, it is used to create a hierarchy of clusters by connecting data points with minimum total distance. Computer graphic like image segmentation, segmenting an image by building a minimum spanning tree of pixel similarities. Approximation algorithms for NP-hard problem, used as a subroutine in algorithms like traveling salesman, Huffman's approximation methods. Thanks for watching this video.